where matrices could be used, okay, and how the matrix multiplication gives you an answer. So another thing, matrices are designed to go into computers so that computers can do math quickly for us. But they also, we've learned how to do them so we can look at the mathematics ourselves. So we're going to look at some word problems, some real life situations that are very plausible, and we'll see how does matrix multiplication help us with these, and what does it tell us. So we've got a company that supplies balls, bats, and gloves to sporting goods stores. And they're supplying to those 4 stores, and that's how much the orders are. And what we could do, and sometimes what I like to do in situations like this, is we could take and put a big square brackets around this to save us some time, and call this matrix A. And we don't have to rewrite. But we can go to our calculator, and we can put that in as matrix A. In fact, let's do that right now. Anybody not have a graphing calculator that would like to borrow one for today? So we go second matrix, we go to edit, and even if there are numbers in there, I don't worry about it. We're just going to replace them, okay? What do we have? We have 4 rows, 3 columns, and then we can just start putting the numbers over top. 70, 30, 22. Okay, so we've got our matrix A written in there. That's the total order as matrix A. Write the cost per item as a column matrix. Now, before we get too far, I'm going to, underneath, because I wrote equals A there, I'm going to notice that it is 4 rows by 3 columns. And underneath the 4, the 4 stood for stores P, Q, R, and S. So I'm just going to write that underneath the 4. Underneath the 3, we have balls, bats, and gloves, and I chose bad letters. Balls, bats, and gloves. They should have sold something else. Looks like this is getting ready for the senior staff baseball game. What could they have sold other than that? That would have been a different letter for baseball. Helmets. Yes, or baseball hats. That could have worked. Then I'd have different letters. But we've got balls, bats, and gloves. We'll have to just deal with it. Okay? Now, in part B, it says to write a column matrix B. Column matrix has 1 column for the cost per item. And we know that the balls, we're going to write this out off to the side right now. Balls, bats, and gloves. And I'm going to put a $sign up there, cost per item. The balls were 8. The bats were 30. And the gloves, 75. And we notice this is a 3 by 1. We're going to call this matrix B. it's a 3 by 1. The 3 stood for balls, bats, gloves, and the 1 was a dollar sign, the cost. And we're going to put this into our calculator as well. So go to second matrix, go to column B, go over edit, number B is now a 3 by 1. Perfect. And this is where matrix multiplication works wonders. If we look at matrix A and matrix B, and we do, sometimes matrices are shown in squares like this, sometimes you don't have to put them that way, but this is how your calculator would show them. We know that matrix A was a 4 by 3, and matrix B was a 3 by 1. So this is good that the numbers match up. So mathematically, they can multiply together. Okay? But in a real life problem, in order for your answer to make sense for what you're doing, not only do these numbers have to match up, but they have to represent the same things in the same order. So this is why underneath this 3, I had written that this 3 was balls, bats, gloves, and this 3 was balls, bats, gloves. And they not only have the same size, but they represent the same thing. If we multiply these together and get a matrix C, we are going to say that C is going to be a 4 by 1. And that 4 by 1, right, because these are the numbers that tell you the size, what did the 4 stand for? The 4 was stored as P, Q, R, and S. And the 1 was a dollar sign. We are going to make a matrix where this is the dollar sign. And we are going to find out how much to store PO, how much to store QO, how much to store RO, what are their total amounts that they owe for each of them. Now on your calculator, really nice, we can go here, we can do A times B. Luckily I can just even highlight that from the 4. Or you can, if you want to do A times B, you can go second matrix, select A, and go times second matrix, and select B. That's going to be our matrix C. We can hit our store button right above the on button and go to matrix C and say, I'd like to store my answer as matrix C, and then it will overwrite whatever was in matrix C and replace it with this. Now, you didn't need matrices to do this. Let's go back to the original question, right? If I asked you, okay, if you read this, and you had that chart, store P buys 70 balls, 30 bats, and 22 gloves. And you know that balls cost 8, bats 30, and gloves 75. So if I asked you, how much does store P owe, you would be like, this is not hard math. It would not be hard for me to say, well, they bought 70 times 8, right? And then plus 30 times $30, plus 22 times $75. But can you see that all that is this row turning sideways and crashing into this column? The 70 hit the 8, the 30 hit the 30, and the number that was there hit the 75. Was it 15? 22. Oh. And you just need to multiply them and add them together. And that wouldn't be hard to do for store P, for store Q, for store R, or for store S. It's not hard to do, okay? So it's not like, oh, this is replacing something that I didn't know how to do otherwise. But what the matrices do is it allows you to hold the information in these boxes, rectangular arrays, and if you notice that something matches up with some of the matrices that you have, you can, in your calculator, instantaneously get a total, very quickly. Instead of having to do all of that mental math on its own, or setting up a spreadsheet, which wouldn't be too hard either, to do this math for you. It's kind of nice. And not only can you check if you're allowed to do it, but your answer has meaning. This is store P, it owes $3,110. Store R owes $2,810. And now that we have that matrix, we can add other things to this. They're like, oh, there's a shipping charge. Right? Matrix D, you have to add 2% to everything that's sold. That will equal, well, if I add 2% to something, I could just multiply matrix C by 1.02. That would add 2% to the total order. Again, on our calculator, we could do this by doing 1.02 times by matrix C, and all those answers get added. We could store this, since we called it matrix D. Store this as matrix D. And this will be the answer to our next question. What is the amount owed to Burgess by each store? We've got that in our calculator. Oh, am I cheating today? I didn't want to rewrite stuff. And again, this is still a dollar sign and P, Q, R, and S. So that's how much each store owes them. And can you see that this is a 4x1? The last question, find the total amount. All you would have to do is add up all 4 of those. Okay? If you wanted to do that with matrix multiplication, you could, because you want an answer in the end that's a 1x1. If I need to multiply this by something, then I would need a 1x4 of all ones, because then when it turns, they would all get multiplied by 1 and added up if I wanted to do matrix multiplication. However, in this situation, it probably would be just easiest to type them into your calculator and add them up. Would probably be faster than creating a new matrix that multiplies them together. But what this allows us to do is it allows us to take a lot of information, which would have a lot of mental math, entered into a calculator, entered into a computer program, tell it to do something, and you get a bunch of answers right away. So let's look at our second example. Did anybody add it up? No. Okay. Do you need to write a number down? No, you're probably okay. Uh-oh. A virus question. Not good. Nurse Bertha discovers that students are either sick, well, or carriers of the virus. I don't know, it sounds kind of scary. I think if there was a Nurse Bertha, I would get healthy really quickly. She finds the following percentages of people in each category. So here's grade 11 and 12. 15% and 25% are well, 35% and 40% are sick, and then an additional 50%, 35% are carriers. They don't show that they're sick, but they're actually carrying the disease around, or the virus. And here are our students, males and females, grade 11 and grade 12. So what we're going to do is we are going to make this matrix A. We're going to note that matrix A is a 3 by 2. The 3 is well 6 carrier, and the 2 is grade 11 and grade 12. We're going to go beside this one, square brackets, and call it matrix B. And we're going to notice that matrix B is a 2 by 2, and the 2 is 11s and 12s, and the other 2 males and females. So the first thing that we notice in this information is that I could do A times B because the middle numbers would match up. And not only do the middle numbers match up, they mean the same thing. That's important for a real life problem. Not only do the middle numbers match up, but they mean the same thing. So how many males are sick? It doesn't tell us in here. Could you do the math to figure it out? Yes, right? If you didn't have matrices, I gave you this chart, and I said, how many males are sick? You'd be like, oh, there's a lot of sort of calculations you'd have to do and adding up and figuring out. But look at what we have here. If I do matrix A times matrix B, I am going to get a 3 by 2 matrix where the 2 is going to be males and females, and the 3 is going to be the well, sick, and carrier. So I can even label this. This 3 is well, sick, carrier. This is males and females. I'll go to my calculator and overwrite the ones that I had. For percentages, are you okay if we put these in as decimals? 0.15, 0.25, 0.35, 0.4, 0.5, 0.35. And at matrix B, which is now a 2 by 2. Maybe 107 and 103. And if I do matrix A times matrix B, 42.35, 37.75, 79.2, What are some of the problems with these numbers? Well, you can't have a decimal of a person. So the questions that are asked here, how many males are sick? So then we go to our new matrix. We get 79.2, so we can say approximately 79. How many females are well? About 42. How many carriers are female? About 76. Did I take the wrong number? Yeah. Females are well? Yes, it is. Should be 38. Thank you. So I think in this question we see, oh, I can see a usefulness of this. If we can organize our data, if we have lots of information and lots of data, you can use it to put things together to solve. Okay? What's the next level of question? They don't put the data into the chart. You have to make your own charts. Okay? So if you were making your own charts, once your first one is made, right? And someone does it exactly like I did it. But then Rhea said, oh, I put my grade 11 and 12 here, and I put my well, sick, and carrier across the top. Is that wrong? No. You can have this chart either way. It would make sense. But then when you make your second chart, when you make your second matrix, it's very important that the rows and the columns match up with the same things. Because if you wrote your males and females here and 11s and 12s up here, you could still multiply your matrices together, and you would get answers that mean absolutely nothing whatsoever. They would just be, oh, there's a number that has no significance at all. So that's a part which becomes important, how you set this up. Because for matrix multiplication to work, the numbers just have to match. For it to work in a real life problem, so that the answer means something, the numbers have to match and the values have to match. So tomorrow's class, well, we'll be able to finish up this, but tomorrow's class, I'll give you some time to work on some word problems. Like, oh my goodness, eh? Data overload. So here we have a bunch of information. And we need to set this up into matrices. All right. Here we go. So, we make a matrix A. I decided to put the beep on the side and the transistors, capacitors, connectors, and diodes on the other side. This is going to sound like it's edited, that I've been swearing or something all the way through. So that's a lot of numbers. Then we look at the other information that we have, and we are told how many they produce per day. So this time, I made sure that I put the beep across the top and the per day at the bottom. Because I want the 4s that are here and here to match up and to represent the same thing. And in both of those cases, they represent the beep. And again, if you didn't have matrices and you had this information, you could solve the first question. The first question says, how many do you need of each per day? Well, we would have to multiply B times A, because B times A is the only way that the 4s match up. And those 4s both represent the beep. And the 1 was per day, and the other 4 was the transistors, capacitors, connectors, and diodes. And in that multiplication, we get our answer right away. Right? All these fancy stereos are getting made. Question B. During August and September, production is increased by 40%. How many budget, economy, executive, and presidential models were produced? Well, we have to think about which matrix we want to use. We want to use matrix B here, because B tells us how many of each thing per day we had, and a 40% increase tells us we're going to have to multiply that by 1.4. So anytime you're increasing something by a percentage, you can multiply that by 1 plus that increase. Same thing if you're decreasing something by 10%, you would multiply by 1 minus 10% or 0.9. And we get our values. Now, depending on the factory, these decimals actually might make sense, right? A 16.8 for the economy model there just means that it wasn't quite done but got finished the next day. That could be possible, right? With people, you don't like to have 16.8 people because you feel bad for that person that got cut off. But this could possibly make sense. Oh. This is like English class, novel reading. So now we are going to try to figure out if it takes 5 person hours to produce the budget model, 7 hours for a person to produce the economy model, 6 hours, and so on. Determine the number of employees needed to maintain the normal production schedule, assuming everybody works an average of 7 hours each day. How many employees are needed in August and September? So again, we look at the matrices that we have. We have an option here. We could make the hours that it takes to do each of them with the beep across the top, or the beep as a column. I have to think, what do I want to multiply this by? I'm going to want to multiply this by B. And in B, my beep was right here. So I need to make my new matrix the 4 by 1, so my beep matches up. That will give you a matrix of how many hours per day. Now this is B. B was not September and August though, right? September and August would be, I think, the one that we figured out with the 1.4. Either way, once you figure out how many hours are needed, divide by 7, because each person can work 7 hours a day. That's how many employees we're going to need. Probably should round up to 36. So tomorrow's class, I'm going to give you a little bit of time to work on some word problems in setting things up.